Hello students, welcome to Fly with Physics. In this video we will be discussing about the very important topic of motion in two dimension, which is projectile motion. So in this video actually we will be starting the new series of projectile motion. Projectile motion has some some different types of problems you have. So we will be discussing all of them, and then after that we will be compiling all these, and we will do more to more numericals at all. Okay, so we will be discussing today the most important topic, which is motion in two dimension, and this is a type of motion in two dimension. Okay, so we will start now. So if any body just moving in a straight line or just moving in a one coordinate, then we can say that this motion is known as a straight line motion or a one dimension motion. But if a body is moving in a two dimensions, for example, see here, this is the example. Here we have a ball and we just throw out the ball, and then after some time the ball makes a path from this. Okay, and the path is like it covers in a xy plane. So we can say that this type of motion is a two dimensional motion, and this is a specific projectile motion where one body is projected and its path is there, and we can calculate different aspects like speed, like what is the range means the distance from the original point and the last point where the body strikes to the ground. If a body is thrown upward, then obviously it strikes on the ground. So this is the range, and this one becomes the height. Okay, height is the maximum height where this ball not going upwards at all. Okay, and then after that it is declining like that. So we will be discussing the projectile motion aspects: what is the height, what is the range, time of light, all that. So now let's get started. So let us move to the main points. What are the main points? First of all, let us assume that here is an object, you say ball, and we are projected the ball like this, and this is the trajectory of the ball, and ball strikes back to the to this point x. Okay, now we just impart the velocity of to this ball, so we can say that the velocity of this ball is u. So what is the initial velocity we are assuming? This is u. Okay, so if we resolve this u with respect to theta, so what is theta? First of all, theta is the angle between the u and horizontal component x. So theta, you just remember theta is just an angle which makes with u and x only. Okay, so if we resolve this component, then what will happen? Then you can say that from the x component we get u cos theta, and from y component we get u sin theta. Okay, so this is the initial velocity of x component, and this is the initial velocity of y component. Now moving to the magnitude part. So in the magnitude part, what will happen? Just magnitude part, we square root of we do the square root of ux square, uy square, and this, and that's all, because there is no z component. So we can say that only x and y components are there. So just put the value and you will get the answer. Okay, and if the vector notation we will take, the vector notation we can say that the vector notation it is equal to I cap, ux I cap, and uy j cap. Okay, so this is the magnitude of initial velocity. This is you can say that it is the vector notation of initial velocity. Then moving to the acceleration part. Obviously when the ball is on the way like this, so acceleration is also there. For example, if we are taking the ball here or object here, so we can say that the this much acceleration is acting on this surface, this direction, and the acceleration is also there in this direction. Okay, so if we take the acceleration downward, only and only g, gravity, acceleration due to gravity is acting, and x component there is no acceleration. Okay, acceleration from the x component, acceleration is not there. Okay, because the only and only the acceleration is imparting is g here. So if we talk about the main thing, that is range and height, so what is the concept here? So first of all, introducing you a range. Here the range meaning that the it is the horizontal distance from this point, this is the original point or origin, and this is the final point. Okay, this is the initial point and this is the final point on the horizon, and this is the horizontal distance between these 2 points, and this is known as range. And we can calculate range at all, but if you remember the formula, then this is the formula to calculate the range. Okay, so the range is equal to u square sine 2 theta divided by g. Okay, understood? Okay, so if we talk about the height, the maximum height that the object can reach, it means that at this point, at this point, this point cannot move upwards now at most. ठीक है, इसके बाद ये ऊपर जा भी नहीं सकता. Okay, so this is the highest point at all, means the object is not moving upwards at all now. Okay, and only just it is declining like that. So if we are taking this one, then we can say that this is the highest point and this is the ground point. So it is the distance between the ground point and the highest point. This is known as the height attained by the object during projectile motion. So this height is equal to u square sine theta divided by g. Okay, so we got two formulas. We will also derive that, no issue, but first of all you will just understand that what is the range, what is the height at all. Okay, now in the next part we will discuss the time of flight. Acha, what do you mean by time of flight now? So time of flight means when object is moving from here to the final position here, so at what time the object is in air. Okay, so this is the time when the object is in air, when the object is moving in air. So this is the time. Okay, time of flight, this is tf is equal to u sine theta. Now the question is that how these formulas arrived, this one and this one. So first of all let us derive this. Okay, so moving to the derivation part, so we have s is equal to ut plus 1 by 2 at square. This is the equation of motion. So let us apply this vertically first of all. Okay, so now in the vertical section, what we assume that this is a complete projectile motion, and first of all let us find the s. So what is s here? Now see vertically s is like that this is the horizontal displacement, है ना? So here the object starts from here and it just moves like this and like this, and at the last it strikes here. So what is the vertical displacement here? Vertical displacement is 0 at all, है ना? This is the initial point and after some time this is the final point on the horizontal same. So there is no vertical motion. So vertical motion is 0. So if we are taking vertical motion, it is equal to 0. So that is why we can say that s is equal to 0 here. Okay, I think you have understood that there is no vertical motion at all. Objects start from here and just end from here. So it means that there is no vertical motion. Okay, so after some time, after you can say that u, vertically u. So what is the u here? Now see u. So in the case of u, we can say that u is u sine theta here. Okay, see u is u sine theta here. Okay, now next one is t. T means complete time of flight. This is complete time of flight. Now this is 1 by 2. This is a is vertical a is a y direction, so it is minus g, and t again tf ka whole square. Okay, so now just you can say that solve this correctly, just rearrange this correctly. We can take 1 by 2 g tf here is this side, and u sine theta tf this side. So here tf and tf got cancelled and one tf is pending. So now we get the formula tf final time of flight, which is equal to u sine theta into 2 also, and g part is there. Okay, so this is one formula we have derived. Now coming to the next formula, let us just apply this equation horizontally. Now horizontally, if we are applying this in horizontal direction, then what will happen? See, s is in horizontal direction is what? So this is the figure, and s is in horizontal direction means the range. Okay, so s is in the horizontal direction means the range. Now u is in horizontal direction. U is in horizontal direction. This is equal to u cos theta. Okay, so this is u cos theta. This is u cos theta, and t is the time of flight here. Okay, now plus 1 by 2, and this is a in x component there is no acceleration, so it is 0, so it is time of flight square. So this one becomes 0 at all. So we have only this r is equal to u cos theta, and here tf means it is equal to 2 u sine theta divided by g. So we have 2u square sine theta cos theta divided by g. And if we are using the mathematics formula 2 sine theta cos theta, it is equal to sine 2 theta. Okay, sine 2 theta divided by g. So this is the another formula. Now coming to the last formula, this is equal to height, है ना. So that case you will use this equation, v square minus u square is equal to 2as. Okay, vertically. So vertically we can apply this, but at which point? We can say that at this point there is the height. This one is the height we have to measure here. So we will just discuss this point also. So at this point there is no vertical component. Vertical velocity is 0, है ना, and the horizontal velocity is equal to u cos theta. So here if we are talking about the vertical and horizontal velocity, we will assume this. Just a minute. Yes. Okay, so here your vertical velocity is 0, है ना. Vertical velocity is final vertical velocity, this is 0, and the vertical initial velocity, here vertical initial velocity is u sine theta. So we can use the u sine theta at all. U sine theta is equal to 2 as. A means we can say g, है ना, because it is vertical direction. So s means h here, and this is minus because minus g, है ना, that is why, and minus got cancelled here, and we have finally u sine theta is equal to 2gh. This one here you can rearrange this, and we will get the formula u sine theta upon 2g. So here are the all three formulas to calculate the range, time and height. U sine theta upon 2g. Okay, so you can just derive from this equation and this equation as well. No other equation you can use. Only use vertical components and horizontal components, and you can easily derive this. Okay, so now coming to the next points that is to be remembered by you. That is, the first point is the very basic point that we have already discussed, that at the highest point the vertical velocity is equal to 0, because at this point there is no vertical motion at all. After this point the ball is moving like downwards, not upwards. Second point, the velocity at any point we can calculate here. So for example, we can take this For example, you can take this point. So according to this point, you can say that uh, this is the horizontal component and this is the vertical component here. So we can say that this is the horizontal component is Vx, and this is the vertical component, this is equal to Vy. Why we are using Vx and Vy? Because we have already assigned u as a initial components, and that is why we are just using Vx and Vy as a as a final components of velocity. So calculating Vx, so Vx is all about u plus at. So u means u cos phi here. Acha, what is phi here, है ना? First of all, see the v, this is the v and this is the phi, makes an angle with horizontal. Acha, this theta and this phi is different, okay, because this is the initial velocity versus x, and this is the v versus x, final velocity versus x. That is why phi and theta are different. And this one is ax and t. T is the instantaneous time, not the time of light. So we can say that ax is equal to 0, so this component is cut, so your Vx is equal to u cos phi. Now calculating about Vy, Vy is u plus at. We can also use this formula. So your u is u sin phi and your a is ay means minus g, है ना? And then this one is t, this one is minus gt, okay. So u sin phi minus gt is your vertical component. So if we combine these both components, so we can say that the vector form of velocity, final velocity here, you can say that any velocity at any point also. So this is equal to u cos phi and u sin phi minus gt, j cap. Now coming to the coordinates part, we can also calculate the coordinates at any point. So for example, this is the point and this is the x coordinate, this is the y coordinate, and this one is x coordinate at all at this point. So this point can be represented as x and y. So we can also calculate x and y using the same equations of motion, है ना? So at first just calculate the x component. We just use this equation of motion, s is equal to ut plus half at square. Here we can say that s is equal to x for horizontal, u is equal to u cos theta for horizontal, and t is the instantaneous time small t, and here ax is equal to 0. That is why this component vanishes at all. And if we are talking about the y axis, then we can say that this one is y and this one is uy. Uy means u sin theta, and then t is the instantaneous time, and then 1 by 2 a means minus g, and t square 1 by 2 gt square. So this is the coordinate for y. So this is the x coordinate, this is the y coordinate. So if we just combine these two coordinates, means just putting the value of t here, x upon u cos theta here in this equation, so we will get the relation between x and y here, and this ultimately this is the equation of trajectory. What is the meaning of equation of trajectory? Equation of trajectory means it is the equation of this curve that it will make, okay, during the motion. So coming to the next part, in the next part we will just calculate the maximum range. So what is the maximum range? Means how, at which angle we can make to maximize the range at all. Means at which angle we throw a ball or we throw any object, so that it could cover the maximum horizontal distance. So this is the concept of maximum range. So we all know that the range is calculated by u square sin 2 theta divided by g. So here if we make the range maximum, so we can make u also maximum and g also maximum. G is constant at all, u is also constant at all, but here theta can be variable. So sin 2 theta will be maximum if sin 2 theta is maximum, means 1. So when will sin 2 theta is maximum? Sin 2 theta is maximum at 90 degree. So here we can say that here we can say that 2 theta is equal to 90 degree. So theta is equal to here 45 degree at all. Okay, so here 90 divided by 2, 45 degree, means if we are throwing any object at 45 degree angle, the range will be maximum. Okay, now for example the range is not maximum, then what will be the other angles at all? So if range is not maximum, then we can say that there may be two angles at all. Okay, theta 1 and 90 degree minus theta 1, two angles can be exist at the same time. What is the meaning here? Now see, for example we have a ball and this is the range, so the range for this projectile and this projectile is same. It means that ये तभी हो सकता है when this theta and this is 90 minus theta, and if this is theta then this is 90 minus theta, then only we can say that the range will be same, and there may be two possible angles at all. Okay, so you must remember this also. So this is the basic of this projectile motion. Now we will be discussing some basic cases also for projectile in the next upcoming lectures. So I hope you will enjoy this lecture. If any doubt is regarding in any point, you can just comment at all, and if you are like these lectures, then please like, share and subscribe. So thank you students.